Welcome everybody, and I'm going to start with an acknowledgement. As always, we respectfully acknowledge the province of Newfoundland and Labrador, of which the city of St. John's is the capital, as the ancestral homelands of the Beothuk. Today, these lands are home to a diverse population of Indigenous and other peoples. We also acknowledge with respect the diverse histories and cultures of the Mi'kmaq, Innu, Inuit, and Southern Inuit of this province. And I'm just going to share the screen for a second to so can you see the screen there? This is the agenda for tonight. We're going to get a talk from Nikolay about interpreting satellite weather data. We've got lots of observation reports, so the weather's current evidence to the contrary may be getting a little bit better. And then we're going to get Nikolay again to tell us about the sky next month, a little bit of news. And then there's time at the end if there's members or visitors who have questions or comments, or people want to discuss some stuff. There'd be a little bit of time for that. For the visitors, I'm not sure how many visitors I saw, but you're welcome. These meetings are open to the public, and if you got here, you probably figured out that you email to info@stjohnsrsc.ca for the Zoom links. And the benefits are a supportive community. If you're a member, you can join the chat group, which is really quite lively. There's a lot of interesting and useful information gets exchanged there. There are these publications, the journal, which you can get as paper or electronically, Sky News, which is a great magazine with information about what's coming up and about topics of interest to people like us. The Observer's Handbook, which is a very useful resource. Members have access to equipment through our equipment director, that's Chris. Lots of telescopes, solar telescopes, some accessories, and hopefully we'll be able to get back to doing some member observing sessions soon. And you can join at the National RASC site. There's also a weekly newsletter and a monthly bulletin from the RASC that members get, and you can request the newsletter. I think I forget, is it the newsletter or the bulletin that you can request if you're a non-member, Randy, or both?
I believe only members can get the bulletin as it says there, right? Well,
okay. So it anyways, good information there, and the newsletter these days also has information about talks that are available from other centers, and I know some of us have been attending those. So with no further ado, I'm going to introduce Nikolay, who's our observing director and a professional meteorologist, and he's going to tell us about interpreting satellite weather data. So I'm going to stop sharing and invite Nikolay to share his screen.
Okay, thanks, Mike. Just going to share my screen now. By the way, do you guys know if Robert is joining?
He may not be.
Okay.
The family thing came up with him.
Okay. The reason I'm asking was because he's the person who was the most interested in this presentation.
Well, it will be recorded. No, I think we're all interested. He was the person who was probably most vocal about it, but I think we're all puzzled about.
He emails me a lot about weather questions. And so he served as inspiration for this talk. So I'm going to share my screen now. Okay, you can see the full screen presentation.
Looks great, yeah.
Okay, perfect. So thanks everyone for joining today's talk and this presentation. As Mike alluded to, I'm a professional meteorologist, and so this presentation ties in well with my career, but also with my interest in astronomy. And in fact, astronomy is what got me into weather, in a weather career in the first place. So this is a nice tribute to that, where I, combine the two together. So today I'm going to talk about satellite imagery interpretation, specifically tailored to our needs here in Newfoundland, and specifically for, with the purposes of astronomical observing. So let's get started. So I'm going to start talking about just start with the background. What are the pros and cons of using satellite to forecast the weather, to do your astronomical observing? So starting with the pros, the biggest one is that forecasts are sometimes wrong. They're static, they're issued, long time ago, a couple of hours ago, whatever, and they're not always right. Most forecasts are also automated, which means that they're produced by a computer, which means that they don't necessarily always have the latest satellite data ingested. And they're also sometimes old, depending on what forecast you're looking at. Proper satellite interpretation overrides forecasts. There's no simpler way of saying it. So if you can look at a satellite image and properly interpret it, this is automatically better than the forecast that you saw that was produced a couple of hours ago. So this gives you an advantage, if you will. And ultimately, this saves you a lot of time in setting up. So for example, if you look at a forecast, the forecast says clear skies tonight, but if you open the satellite just before you set out to set up, and you see that there's clouds coming, well, there you go. You decide to not go observing, and that will save you time setting up and disappointment. So what are some of the cons of using satellite for this purpose? Well, the accuracy decreases with increasing lead time. What I mean by that is the farther out you try to predict the clouds using satellite, the less, the lesser the accuracy. And that's, some of the, one of the main reasons for that is that clouds don't just move from one area to the other, they also change. They dissipate, new ones develop, etc. Another one is that it cannot be used to plan for the days ahead. That's something that, is the realm of the actual forecasts. Okay. Typically, it's not usable more than 12 hours ahead of time. Even with 12 hours is a bit sketchy because you got to time it pretty well. If you see clouds approaching and you're like, oh, that's 12 hours away, I would put that at a kind of a moderately uncertain forecast because of the significant lead time of 12 hours. Lastly, infrared images are used at night and slightly harder to read than visible images used at day. And I'll talk more about that. But essentially, when you're looking at satellite data, it's either a visible or an infrared image. And when it comes to observing, because it's usually done at night, you will be looking at infrared imagery, which are slightly, harder to read than visible images. Okay, so I'm going to move on to the next slide. This is a bit of a kind of a weather primer, if you will. It does not address how to interpret satellite data. It's more of a how do you get cloud, which I think is going to be helpful to inform the the conversation that follows after that, which is the prediction. So some basics, as I'm sure everyone knows, high pressure means settled weather, although not always clear, and low pressure means unsettled weather, which is rarely clear. So one of the ways to get clouds is when you have an approaching storm or an approaching low pressure system. So what happens in that case is first you get high cloud, then as the low approaches, you get middle cloud, and then finally you get the low clouds. That's the classic example. There's obviously variations. Also behind low pressure, St. John's and Newfoundland in general are very well known for getting clouds behind low pressure because of the ocean. That's the way it works with the cold air moving over the ocean. So what happens is you get persistent low cloud, typically scattered. Those are the so-called onshore flurries or ocean effect snow. They are fast-moving convective clouds formed as cold air behind storms moves over the warmer ocean. And that's one of the main reasons why we get more cloud than other places, is because those onshore flurries tend to develop behind storms. Okay. In most other places, if you read a textbook on meteorology, you will read that once a cold front from a storm clears you, sky's clear and it's beautiful. Not here though. Okay. And then there's the third way to get cloud in St. John's, which is under high pressure. Again, another reason why we get more cloud than other areas. Most people learn that under high pressure you get clear skies. However, that's not necessarily the case here. So continental climates is where you get the clear weather under high pressure. Maritime climates, on the other hand, especially the cold ones, such as ours, get clear weather, but also fog under high pressure, and sometimes just low clouds. So another way to get cloud with high pressure is, you get daytime cumulus clouds. They're typically low clouds and typically don't grow to showers in St. John's. However, they can grow to showers over central Newfoundland and then impact your observing in the evening once they kind of move with the wind this way. And I'll talk more about that in a little bit. In the winter, our lows or our storms are so common that they actually squish the high pressure ridges, and that leaves little time for clearing skies. And that's one of the main reasons why it's so hard to get clear skies here in the winter in particular. And I'll show you an example of that. Also in the winter, high pressure ridges are always in a battle between the ocean effect snow behind lows, so this one here that I talked about, and the high cloud approaching from the next low, this one here. And so they typically only bring a few hours of clearing. So that is your explanation, if you will, why we get short-lived clearings in the winter. So without getting into too much detail, here on the left you have a pressure map. The L's signify low pressure. You will see that there's a low pressure over the Maritimes. There's a low pressure east of Newfoundland. And right over Newfoundland, this kind of thin, elongated ridge of high pressure that is getting squished by those two lows on either side. And here to the right is the corresponding satellite image from the exact same map. Here is the massive cloud system from the offshore low, kind of low clouds, onshore flurries. And here is the massive cloud system from the approaching low, which is the high and middle cloud. And right here in between those two in St. John's, it's clear, but it's not clear for very long. Also, there's these cloud streets here. That's also the ocean effect snow behind this low pressure system. This is sea ice here, by the way. I think that was very recent. That was from March 25th. So hopefully this sheds some light into our problem here. Okay. So I'm going to talk about what kind of forecasts can you do with satellites, specifically for the purposes of astronomy. The first one, obviously, cloud cover. You can see the clouds on satellite, so you can predict your clouds. Most things that you see moving on satellite are clouds, so it's pretty safe to assume that. Occasionally, it can get mistaken if there's like sea ice moving. It kind of may look like cloud, but for the most part, anything kind of white moving is a cloud. So that's the first thing you can forecast. The second thing you can forecast is cloud height. And cloud height is important because you can use that to infer your seeing or your transparency. Okay, so that is something that you can distinguish with the visible and color satellite imagery. So, for example, high clouds, they are thin and wispy and widespread on visible. And also they are bright white on infrared image. Okay, and I'll talk later, how to look at visible, how to look at infrared. I'll actually go to some websites and show you all this. But this is just a little bit of a theory background, if you will. The high clouds reduce transparency. However, they can act as a helpful filter when observing bright objects such as the moon and planets. And they can actually help when you're observing a very bright object. Medium level clouds, they are fairly widespread. They look thicker on visible than high clouds do. And they have a medium white color on infrared, okay? Typically, when you see those, that means that observing is not possible because they are fairly thick. And the only thing you can see through medium level clouds is the sun and the moon. And once they get, very thick, you're not even able to see the sun. But that's when you get those beautiful halos ahead of, approaching storms. You do get them with medium level clouds. And then there's low clouds. Nope. So low clouds they can be scattered, they can be widespread, as you saw in the previous image with the offshore low. They are fast moving on visible, and they look dark on the infrared image. They're typically the thickest and can signal incoming precipitation. Unlike high and medium clouds, in St. John's, low clouds are often scattered and can mean alternating periods of cloudy and clear skies. I'm sure you're very familiar with that. I think in Newfoundland, they're colloquially referred to as sun flurries, when it just keeps changing back between flurries and clear skies. That's what's causing it, okay? Now, the third kind of thing or phenomenon that you can forecast with satellite imagery is transparency, and that's something that I'm sure many of you are highly interested in. I was able to list 3 sources of poor transparency in general and especially here. So, from a satellite perspective, the first one is thin, high clouds. They're one of the main reasons for reduced transparency. They just add that, slight filtering of the sky, and that automatically drops the magnitude of everything that you see by a couple of magnitudes. I'm sure you've all experienced that. Another one is the formation of radiation type fog in the summer. and radiation type is the one that forms in clear skies, light winds, and humid air. That's a second fairly common reason for reduced transparency. I'm sure you've also experienced that. I remember very clearly one September a couple of years ago, we were in Butter Pot. All the models, all the forecasts were saying clear skies. And all of a sudden, the transparency just started dropping and dropping and dropping and dropping. And then you could only see the brightest stars at that point. And the reason for that is that radiation type fog is not very well forecasted by computer models, and so by, you won't see it on the forecasts many times. Again, if you know that there's clear skies, light winds, and humid air, especially early in the summer, it's a pretty good indication that you might get that type of fog. So that's that. And then the third source of poor transparency that you can kind of deduce with satellite is in the spring and summer, as I'm sure you've seen it. Wildfire smoke, generally from Western Canada and the US, can travel all the way here and reduce the transparency, and is almost never forecasted by, in forecasts by public sources. So if you see a forecast with clear skies, but you know that there's wildfires happening out west, have a look at the satellite and check for some plumes of cloud moving from that area, because that can absolutely destroy transparency, even all the way here. So that's transparency. Now seeing, that is something that cannot be precisely forecasted with satellite, but it can be inferred. And here are 4 scenarios for that. Summertime fog, typically, if you can see summertime fog on satellite, you can generally pretty safely infer that seeing is excellent. As long as, of course, the fog is not completely blocking the view, because then there's no seeing. But the reason for this is that this fog usually forms in very light winds, and forms also under high pressure systems, and those are typically associated with really good seeing. Scattered low clouds, they typically mean poor seeing, especially if they're fast moving. Reason for that is that they, like I said earlier, they form behind storms where the atmosphere is very unstable, and so it's very gusty, very windy. That creates a lot of turbulence, and the seeing is poor. Then there's medium clouds, and they typically mean average seeing. It could go either way with these ones. It really depends on the situation. And then there's high clouds, which typically mean average to good seeing. They are associated with high pressure, and high pressure, like I said, is associated with good seeing. Okay, so these are the 4 main astronomical forecasts that you can do by using satellite. Okay, so now I'm going to talk about the 2 satellite imagery types that I've already referenced a couple of times. So the first one is visible. This is the picture here on the top right. That's a visible image. The one on the bottom right is the infrared image, and they are the exact same image, just a different channel. So the visible one, for those of you who are interested, the bandwidth is between 0.4 and 0.7 microns, corresponds to the human vision. It is high resolution, and it is only available in the daytime because this is the only time when there's bright light. It is excellent for seeing through clouds. And what I mean by that is you can see if there's several layers of clouds on visible sometimes, and that can help you make a better forecast. For example, right here, I can see that there's these kind of wispy clouds approaching, Newfoundland. And down here, there's kind of a different looking, more stratus looking clouds that are over, Newfoundland already. There's this line of clouds right here over the eastern Avalon. So you can tell the different layers of clouds a lot more easily, because this is, as it appears to the human eye. With infrared, so that's the second type, it's located at 2.2 microns. What it does is it detects temperature, okay? So that's a difference. It does not, the visible is the way you see it, but infrared, it just detects differences in temperature. So it is also lower resolution than visible, which is a disadvantage for astronomy. It is available day and night, so that's the bonus for us. On infrared imagery, especially the ones that I'll be showing from this website that I'll give you later, darker means warmer, brighter means colder. Okay, so in this image here, these clouds offshore are darker, and so they're warmer. These clouds over here approaching Newfoundland, they're brighter, and so they're colder. And the reason why one cloud is colder than the other is because of the height. These clouds here are much higher in the atmosphere, so they're colder. And that's why those are the high cirrus clouds, whereas the ones offshore, those are the low stratus clouds. So that's how it works. And of course, you can see these darker patches of clouds here that are the low clouds that I was talking about here on the visible image. So it's, even on the infrared images, it's easy to tell which cloud is which, but infrared is, arguably a lot harder to interpret than visible imagery. So because it's not what you would see as a human. And the surface that you're seeing on infrared could be anything. It could be a cloud, it could be water, land, snow. All of that could look different on infrared as long as it has a different temperature than its surroundings. So right here, if you were to just look at this infrared image, you might mistakenly think that this white area here over the Avalon and northeast Newfoundland is some kind of a cloud. However, if you compare that with the visible, you'll see that that's actually clear sky. All that this is detecting is the temperature of the surface, which is, land and water here. They're actually pretty similar temperature this time of year. I took this on March 25th last month. So something that I'm going to talk about is that it's critical to compare the two images. And then if you have to only use infrared once it gets dark, then at least you know what's what. Because if you don't have that reference with the visible, you can get mistaken. You can mistake clouds for clear skies. Okay, the next slide. So I'm actually gonna show you some scenarios now. I have 5 or 6 scenarios that include actual interpretation of satellite imagery. So I've tried to capture as many different scenarios as possible, both from winter and summer. So I'm gonna play some videos for these as well. So the first video that I'm gonna show you is that battle for clear skies between the two lows that I talked about earlier. Do note there's going to be a thin area of clear sky. There's going to be some sea ice. There's going to be some orographic clouds on the Avalon, and some offshore low cloud and fog, some approaching high cloud, and some snow on the ground. Okay, so let's try and see if we can find all of these things. So I'm going to play the video now. Can you see the video playing now? Okay, So, whoops, where did it go? Okay, so this is your thin area of clear sky between the two lows, okay? Eastern Newfoundland and kind of north of Newfoundland. There's your sea ice up here, barely moving, kind of a beautiful pattern. There's the offshore low cloud behind the offshore low. There's the high cloud approaching from the next low from the Maritimes. Now, when you see something like that, you know, you might think, oh, I actually have a couple of hours here to observe because I'm between those two systems and it's going to be clear. And then you go out and it's pretty cloudy. Well, that's when it's always very important to pay attention to the details. So there's two details here that can actually tell you why this isn't a very favorable observing situation. One is that those thin wispy clouds, you will see them kind of breaking and becoming more scattered ahead of the system, but they're still very, very well clipping the St. John's area. So you're definitely going to have some scattered high cloud if you go out in this case. Problem number two are these orographic clouds. So if you focus your attention here on this line over the Eastern Avalon, right here, you will see those low clouds kind of developing off of a stationary line. Those are orographic clouds. They're caused by the increase in elevation over this part of the Avalon. You can tell that they're caused by the increased elevation because they form over the exact same area right here. And you'll see that the wind blows them over the city. And so that's actually it's a bit problematic. Maybe not so much if you're, you know, further north, but if I was in Mount Pearl here and I saw this, I would never go out because it just doesn't look good. I mean, yeah, you're gonna see some clear skies. It's not gonna be terrible, but if you're looking for decent observing, this just won't work for you. So now so this is the visible image. So now I'm gonna show you the same picture but with infrared. Okay, so this is the infrared image, and sometimes this is all that you have to work with, because let's say you decide to do this at 2 a.m. There's no visible, the only thing you have is infrared, and now you're trying to figure out what's what. There's this area here over us that you don't know what it is. Is it fog? What is it? But if you have it referenced with the visible, you know that that's the clear sky. So that this is helpful. And then there's the dark clouds, that's the offshore low. And then the bright white clouds, those are the high clouds that are approaching us, okay? You can actually see the orographic clouds quite well here. That's the dark kind of line right basically along the spine, if you will, of the Eastern Avalon. So those are not great to go out and observe in. Okay, so that's that. I'm gonna move back to the presentation and go to scenario 2. So on this one, we're gonna be looking at different layers of clouds on infrared. Do note a couple of things: low cloud off and over the Avalon, mid cloud overspreading the Avalon, high cloud approaching from Buren, some patches of clear sky approaching Cabot Strait, and an intense system well southeast of Newfoundland. So here's the video. So this is an infrared image. Here's your, just in case you can't see this very well, but the blue outline here, that's Newfoundland. So well southeast, there's this intense low that's departing. However, if you look at the Avalon, there's all these different shades of white and gray. And that's basically an indication that you have several different layers of clouds, and that's never good for observing. First of all, you have this kind of very dark cloud down here, here. So that's usually the lowest cloud. That could be fog or just very low cloud. And then you have this more of a milky, kind of medium white color approaching the southern Avalon. And finally, the one from the Buren, that's the high cloud. That's the brightest white. So you're dealing with 3 different layers of clouds here. Very much not good for observing. Over here, though, if you're looking for clear sky, though that part here behind the system does have some clear skies approaching the Cabot Strait. So that's another example of how you can see different layers of clouds. And now, example number 3. This one is about fog. We're gonna be experiencing more and more of that as we move into summer. Very much a summer type event. I have seen it in the winter, but obviously it's rare. So do note on the visible image, fog is essentially hugging the coast during the day. And then what happens is on the infrared image, after the visible is not available anymore, the fog begins to spread inland from the southern shore and towards St. John's. So here is the visible. Here is your fog kind of during the day. Doesn't really want to spread inland because the surface is warm. It's heated by the sun. It's causing the fog to evaporate. So the fog is just lingering over the water. And in fact, it's getting pushed out here in St. John's. But it does wrap around a bit here on the southern shore. And in fact, if you were in, let's say, Trepassey, which I think is down here, the fog is actually, you can see it spreading inland. So if you looked at this and you didn't give it, a detailed enough look, you may mistakenly think, oh, it's clear everywhere, I'm good. But if you were in Trepassey at this moment, it's going to be overcast and foggy. So you may wonder when you see something like that, okay, what's going to happen after dark? Is that fog going to spread inland, or is it going to stay along the coast? Well, I'm going to show you the infrared image directly following this visible image. And let's see if you can answer that for yourself. So here is the slightly darker patch that was clear. That's kind of moving to the east. Okay. And there's this fog that was down here. That's slightly brighter color than this dark one. I don't know if you can see it. I can see it pretty clearly here, but the fog is spreading all the way to Holyrood here. It's just on the doorstep of St. John's. So if I saw something like that, if I'm in St. John's and I look up, it's going to be clear. It's going to be perfectly clear, not a single cloud. But if I look at satellite and see this fog spreading like that from the southwest, I won't go out. This just, it's only a matter of an hour, maybe, if that, before that fog completely overspreads the city. The one thing, though, with southwest winds and fog coming from the southwest is that the fog does break up a little bit once it reaches St. John's, just because it's kind of far from the ocean in the southwest. But it's usually not enough of a break to make an observing session worthwhile. So there's that one. Now I'm gonna go to scenario number 4, and that one is summer convective cumulus clouds on visible satellite. Do note here the numerous scattered clouds, some clouds growing to thunderstorms in central Newfoundland, some remnant terrain-induced cumulus clouds over Avalon's high terrain. And in the summer, that's an important tip to remember. Remnant clouds from central thunderstorms can make it to the Avalon but typically they dissipate before midnight. They tend to be fairly poorly forecasted because the reason for that is that thunderstorms usually grow bigger with their cloud system than what models have them. And then those clouds end up moving to the Avalon, and they can take you, by surprise. So let's have a look at the video. Okay. So there's the clouds that I'm talking about are all of these numerous hundreds of puffy clouds here over central Newfoundland. You will see them developing. First it's clear, then they develop, then they grow, and then there's this bigger one here over Gander, and that's your thunderstorm. So you will see that they're moving towards the southeast. There isn't a whole lot in the Avalon, but those clouds will eventually make it to St. John's before they dissipate. The good thing, like I said, is they tend to, because they're diurnally forced, they develop in the sun's heat. They do dissipate after dark, but they can kind of give you a little bit of trouble in the evenings. The clouds that form over the Avalon in the same matter, you will see them here, are substantially smaller and not as extensive or expansive, because it's usually colder on the Avalon in the summer than it is in central Newfoundland. So there isn't as much heat to help grow those clouds. So you might see a little bit, and typically as soon as the sun sets here, those clouds will dissipate. But you will still, in many cases, get those clouds from central for a few hours in the evening when this happens. So pay attention to what happens in central Newfoundland in the summer, if there's thunderstorms, and what the winds are. Okay, so there's that. Oh, there's a cute, this is a little bonus that's not related to anything I'm talking about, but it's a cute little vortex that I, right here, basically, it's spun off over the southwest tip of Newfoundland. That's the only reason why I have this video. It's actually from 2019. I was very lucky to have this video for this purpose. Took it for a completely different reason, but it shows pretty well how the thunderstorms work and how that can impact your observing. So there's that. I think that might be the last one. So those are onshore flurries. So this is strictly a winter forecasting scenario. When you get cold northwest winds in the winter, they bring onshore flurries. A small shift in wind direction can mean clear skies versus flurries. So it's very important to pay attention to the wind direction in those cases. In either case, you're seeing is going to be poor, but transparency will be excellent whenever the sky is clear. And here's your magical number, which I've shared before with some people, and I'll show you why it works. If your wind direction is greater than 320, which is a northwest wind, that means that you will get onshore flurries. If it's less than 320, which is more of a westerly wind, you will get clear skies. And the reason for that is that the wind is going to be coming off of the kind of the landmass of the island, as opposed to the north and the ocean. The rule is only valid on cold winter days. And here is the image that shows why this works very consistently. Actually, this is in the next slide. I'm just going to move to the next slide. Okay, so here on the left is an example where your wind direction is greater than 320, and on the right it's less than 320. I actually took this in December, so this is just two consecutive days. One is December 16th, and the next one is December 17th. Here on the left, you will see that the observations from St. John's Airport show wind direction, which is intense, by the way. So 35 means 350, which is a northerly wind. Wind direction is kind of north-northwest, and your weather is blowing snow and snow showers, and mostly cloudy. You shift that wind a couple of degrees, and now it's more of a 320 and all the way down to 290. This is what happens. The clouds actually get pushed offshore, and you end up with clear skies in St. John's. You will see here on the observations, it's clear or mainly clear. So this is an excellent rule of thumb that I use all the time in the winter. If I want to observe, especially when I know that these onshore flurries are occurring, and I want to decide, is it going to be, what is the direction that they're going to be going in. I hope you can see this in the two images, but here on the first one, everything in kind of on the northern Avalon and central kind of northeast coast is basically enveloped in cloud. It's overcast, and here the exact same area is actually clear. Okay, so there's that. Oh, I guess I have one last scenario. So I'm going to use this example to show you how to correlate visible with infrared imagery. Do note that at night you're stuck with infrared and it may be hard to tell what's what, like I said earlier, and the key is to correlate that with visible. So here is your image. I already showed that image and kind of talked about it extensively, but the biggest thing here is to recognize that this kind of whitish or grayish area here over us is actually clear sky, which you can correlate with the visible image. Okay. So here are some tips, kind of summarize everything that I talked about so far. First, play the visible the visible loop, and then infrared to correlate features. Unless you're really confident in your infrared satellite interpretation, I would suggest that you do this. Always zoom in and look for tiny clouds that may not be obvious when it's zoomed out. Okay, tiny clouds can make or break an observing session. I can't tell you how many times I've actually gone observing because I've looked at the satellite for a few seconds and said, oh, it's clear, let's go. And then I go out and there's clouds and I'm like, why? Like what's going on? And then I look at the satellite and zoom in and actually see, oh, okay, there's actually little clouds here that I completely missed. Even if they look tiny on the satellite, they can be large enough to ruin your observing session. This is especially true for those orographically induced clouds that I was talking about near the Avalon higher terrain. They can be very difficult to see sometimes, but they're certainly troublesome enough to make a note to pay attention to. Fog is very difficult to see on infrared due to its similar temperature to the ocean. Remember, infrared only detects temperature. If the fog is the same temperature as the ocean, it's going to be very difficult to see. And that's why it's important to look at visible and actually see the fog, when that visible is available. That's just what I said. So if fog is found to be moving towards St. John's from the east or north during the day, it will almost definitely mean a foggy night. There's very little kind of to stop that fog from moving inland and remaining there for all night. However, if the winds are very light, there is a small chance that it will just remain along the coast and not move too far inland. So that's it's a good time to go somewhere away from the ocean. If fog is found to be moving towards St. John's from the southwest, it will likely break up over the length of the Avalon and often impacting the city with remnant low clouds that tend to dissipate. There will still be clouds. It's just not going to be as overcast as this first example. Compare the satellite image with different forecasts, see which one to trust. That's an important thing to do. Let's say you're looking at Environment Canada's forecast and it's saying clear, and you're looking at the weather network's forecast and it's saying cloudy. The two forecasts are completely contradicting each other. And so in that case, what you do is you look at the satellite image and try to see the forecast for several different cities maybe, and see which one is actually doing better, and try to interpolate that into the future to make the forecast for your own city. If you're using spotwigs.com, which I know a lot of you do, in conjunction with satellite, there's two important tips to remember with these models. I generally don't recommend using Spotwigs, but I know that people just do it anyway. It's kind of like, getting sick and making a diagnosis using Google. It's essentially interpreting scientific data without the qualification to do it. And the reason for that is that Spotwigs uses raw model data as opposed to something that's been worked on and interpreted by professionals. But anyway, if you're doing that, the GFS model, which is one of the main models that you see there, is better built for high and mid-level cloud. So if you see that the GFS model gives cloud, but the other models don't, you can usually deduce by that alone that GFS is handling some mid or high level cloud that the other models just can't handle very well. On the other hand, the RDPS, which is the Canadian model, the GFS is the American one, RDPS is better built for low cloud. It captures those onshore flurries of low cloud behind lows really well, much better than the GFS, with one of the reasons being that it's a much higher resolution model. So if it's a cold day, if you're expecting onshore flurries, this is the model to go with. And there's many other biases, but this is one of the biggest ones that you may encounter. And lastly, public forecasts tend to have a clear bias due to the model's difficulty in resolving small-scale clouds. So what this means is that, at least in my experience, it's a lot more common to see a clear forecast and for it to end up being cloudy than the other way around. And the reason for that is that there's these smaller clouds that are not very well modeled that end up kind of making it cloudy. So there's that. And lastly, here's the sources where you can look at this data. The GHOST 16 satellite is where this data is available. That is basically the superior satellite for weather forecasting. It's also the newest one. It was launched in 2017. So it's only been operational for a little over 4 years now. And luckily, it just barely covers Newfoundland. A lot of these satellites sometimes kind of cut off over weird places, but we're very, very lucky that it just covers us and actually cuts off to the east of Newfoundland. The image is available on several sources. The one that I use the most and I think is the best is called the College of DuPage. This is the link here. I can actually go to it and show you what it looks like. Okay. So there we go. So what you got to do is select your region. Under the sector, I would typically go to regional sectors, and then click on this one here. I would even go to sub-regional because that provides a better zoom. So I'm going to click on Newfoundland here. So this is the visible image. It's black because it's dark. You cannot use it. So I have the visible selected here. So I'm going to change it to shortwave infrared. That's the one that I've been using. If I switch to that, you will see our current cloud situation. Down here, you click play, and you see all sorts of clouds moving. Again, you do encounter that problem where you don't know what's what on infrared. Like if you look here over west of Newfoundland, which of those two is the clouds? Is it these here, or is it this other thing here? And the way you figure that out is you go to visible, and you actually see that it's this thing to the south that's the cloud. The rest is actually a fairly clear sky. And right over western Newfoundland, there's a very beautiful line. That's the edge of the system that's kind of moving over us right now, and it's going to give us rain tonight. There was actually, if I change the number of frames, let's say to, I don't know, 200. I was looking at the satellite yesterday and thinking that it was an interesting day to forecast. Okay, so I'm going to move this to, so this is yesterday evening. As you may remember, yesterday was a pretty clear day. But if you were considering observing, you will see that there's a lot of these thin kind of streaks all over the place. So that's a scattered high cloud. And although it's not extremely widespread and completely out of the question, it will cause lower transparency. So if you looked at this and you saw this cloud, that will be indicative of that. There's of course these little, again, orographic clouds developing over the Avalon. They don't seem to be very problematic because they're well away from the city, but it's this scattered high cloud that's problematic. Of course, if I was observing planets, I wouldn't care because this wouldn't have any impact. But if you were looking at deep sky imaging, this could cause your transparency to be lower. Okay, so I think that should be it. That's the end of the presentations. If you have any questions about this presentation or just weather in general, please email me. I'll be happy to help you and talk about weather because I love doing that. If you want another weather presentation for astronomical purposes, please let me know. There's other topics that I can cover. I can go into more detail about how to forecast seeing. I can go into more detail on how to forecast transparency. It's just a matter of, if there's interest in that. I never know how interested people are in these things, whether they consider this to be too much trouble to go through or whether they actually find it helpful. So depending on, if you guys find that useful, I can certainly consider doing more in the future. So just let me know. And I wish you clear skies. Thank you.
Great, Nikolay. Thank you very much. There's a lot of information in there. So do we want another weather presentation? I think we will. We'll let you know. We'll discuss it. But yeah, I thought that was great. So if people have questions, they can unmute or use the chat. Or okay, so Marcellus says, thanks, Nikolay. That was way more informative than what Snowden delivered a few years ago. But that was probably Snowden. But and so Nikolay, in general, as systems are moving across, just from looking at sort of the videos you showed, it looked like the time for something happening in a system to get from central to us was about 3 hours. Is that pretty typical, or is that?
Yeah, I'd say that's pretty accurate. Depending on the signals are stronger, it gets faster. Also, if the thunderstorms are more widespread, more serious, they can have a larger cloud system that actually.
I'm not sure if that's. I'm
Your
having
audio's
trouble
gone,
hearing
Nikolay.
Is that me or is that Nikolay's end? Randy?
You're hearing me now?
I think as Nikolay, maybe if you stop sharing, you might it might be using too much bandwidth, right?
Can you hear me
Hi,
now?
Nikolay.
It's pretty garbled.
Okay.
Everyone's okay but you.
Yeah, so Richard says, great presentation.
Oh, yeah.
Yeah, that's funny that, oh, so Nikolay looks like he's rejoining now. So maybe I will continue with the,
Robert's on now too, by the way. So
yeah, Robert actually came in very close to the beginning. So you got most of that, Robert, right? I think Nikolay was only about a minute in when you started, so. Anyways, I will,
he's back now.
oh, okay, so I will stop sharing and,
Here's that.
so try again, Nikolay. Oh, he's connecting.
Can you hear me now?
There you go.
Yep.
Oh, yeah. Yay.
Okay. Don't know what's going on.
Yeah, it was a
Nikolay.
bandwidth thing, I suspect, but I'm gonna make you co-host again.
Okay. Nikolay, can I ask you a question? I noticed you didn't do nothing on the jet stream, and with planetary, I've noticed just the movement of the jet stream gives me fantastic pictures to the crap.
Yeah.
Oh, yeah.
Yeah. So the jet stream has a very, very serious impact on seeing. You can have very light winds at the surface. However, if you are under the jet stream, the winds aloft will be so high that you end up with these steady but kind of blurry images in the planets. I'm sure you've seen that. If it's the other way around, if the winds are strong at the surface but light aloft, if you're not under the jet stream, you end up with shaky images that are a little bit clearer, but they're still shaking. So it really depends on where those high winds are, and with the jet stream, you just have high winds aloft, and it's kind of the seeing drops to kind of average. It's steady, but it's just not a clear image. I've seen that a lot observing Jupiter. Surface wind is light, but you're under the jet stream and you just see this blob with just the two bands across. That's about all you can see. So the jet stream is very important for sure.
Okay, and Jamie Kenny had a comment. Thanks, Nikolay. A further talk perhaps on interpreting Environment Canada's astronomy forecast page would be interesting. So that's
I can do that.
one to keep in mind. Not next month maybe, but maybe in the fall.
Sure.
Nikolay,
Yes.
we've had a couple of instances, one on Astronomy Day in Pippi Park, and another during the transit where we went down around Trepassey. And we used to have a cloud appear and just went around and around and around overhead of us. Strange times. Clear around everywhere, but the cloud up right up where the sun was, just went around and around for the whole time.
Well, that could very well be those orographic clouds that I was showing that just are stationary.
Yeah.
They just develop over where the terrain, increases, the elevation increases, and that forces the cloud to develop there. That would be the only explanation. The other one is that it's just very light wind and the cloud is sitting in one place, but that's a bit
Very
less
frustrating.
likely. Yeah, I know what you mean.
Well, Nikolay, CBS has often been noted to have a mini climate. Is that what, I don't know if that's the right word.
Yeah.
Microclimate or something. And where I used to work in Seal Cove and drove back and forth for 20 years, often I would see it would be less moisture in CBS than it would be when you crossed the hills, I guess, at around Topsail.
Yeah.
And I'm not sure if that's because of the prevailing winds coming off of land and then dropping towards Conception Bay or what, but is there, is there some reason for that?
Yep. The microclimate of CBS is well known. It's real. It's not, dramatically different from St. John's, but the difference is significant enough where people can notice it. So it's not just anecdotal. I think it's very real, and I think there's a couple of reasons for it. Number one is it is protected by land to the east, whereas St. John's is exposed to the east, and the east is kind of an evil direction to be exposed to here because, of course, of all the fog and all the cloud that comes from the east, which very often makes it to CBS. But in the more marginal scenarios, it can just affect the city but not CBS. So that's one of the reasons. The other one is you mentioned the prevailing winds. There tends to be a kind of more of a land fetch for the wind to travel. It's a little bit closer to the landmass of Newfoundland, which of course, as you know, is much more clear than the Avalon. That Clarenville is many times more clear skies than anywhere on the Avalon. So there's that, and I'm sure there's other reasons. I think I don't know what the elevation is in CBS, but I feel like it might be a little bit lower than places like Mount Pearl or the East End. So that's probably also a factor. All they have there for water, and really water is what the problem is just Conception Bay, but it's not a huge bay, and it's kind of to the north, which is not a very problematic direction to be exposed to. So there's a lot of little things there. It's a small difference, but it is there.
Related to that, Robert, you probably noticed I left St. John's one Saturday to go out to Topsail, visit a brother, and we'd had 5 or 6 centimeters of snow in St. John's. Halfway down over Topsail Road, just past the hill, was a line across the street, snow on one side, clear on the other side. No, not a speck of snow.
Yeah, I've often seen driving it over 20 years every day, Monday to Friday. You would certainly see if there was a difference in weather patterns, and there's absolutely no doubt about it. But like Nikolay said, it's not every day, but over a long period of time, you can see that it's kind of at least every like third day or something like that, so that you can see that you have more time with some sunshine or clearer skies, living in CBS than living in Mount Pearl or St. John's. I don't know if it translates into clear sky at night because I don't have any.
Well,
I don't have. I did live out there for in CBS for a year or two, but that was a long time ago. So I can't really.
John Nugent's from CBS, and he's confirming that it's always nicer. Yes.
And of course, Jim Johnson would agree too.
Robert, I see the same thing between Grand Falls and the Bay of Exploits where I live. I travel back and forth there just about every day, and there's always a difference in the weather in both locations. Usually it's windy and rain and everything in the Bay of Exploits, and then you get into Grand Falls and it's clear. And you get out towards Norris's Arm, and that's where usually it cuts off. So see several days in a, most every day in a month. There's some days it's the same, but there's a lot of days you can see the difference.
Yeah.
Well, you live in the best spot in Newfoundland for observing. That's for sure. It's, I haven't looked at statistics, but I would imagine Grand Falls is the clearest spot in Newfoundland.
Yeah, well, I'm not actually in Grand Falls. I work there, but I'm in the Louisbourg area, which is a little bit more out towards the bay there. So we do get a little bit more cloud there. Yeah.
It's
I have a
definitely
question.
Much better than St. John's, that's for sure.
Yeah, maybe, yeah. Although the last few weeks it hasn't been good. We've been had a lot of bad weather the last 3 weeks, of course. But there's an app I use. It's called Windy, and it's got satellite images on it and cloud images, and I could look at it all night long when I'm in my observatory, and I can see the clouds. So is that really accurate, or is that just what is that I'm looking at there? Like you said earlier that you can't see the cloud in the nighttime, and I understand that because it's dark.
Yeah. I think Windy shows the cloud forecast by directly taken by the models. I don't actually use it for a whole lot, and I'm not sure if it has actual satellite imagery or modeled cloud. That's something that I can check. But if it is the modeled cloud, that's just because that's what Windy shows. Windy just provides raw model data. It doesn't provide a human forecast. It's very similar to Spotwix in that regard. It's just more, it has more features, that's for sure. But I actually haven't checked to see if they provide an actual satellite image or just the modeled. But the modeled image, satellite image, should be pretty helpful in and of itself, because you can use it to compare with the actual satellite from that website that I provided, and then see how well it's performing.
Okay, well, we should probably move on, so maybe people can unmute and thank Nikolay again for a really great talk, very informative. So thanks a lot, Nikolay.
Thank you.
Excellent job.
And so I'm going to share the screen again and go through member observations, and we've got quite a few, which I guess is encouraging. That must indicate that the weather's starting to get a little bit better. So I ask people if I invite you to comment about your contributions. I've taken these mostly off of the group's chat list. If you could be concise, because we don't want to go on too long. And I'm going to start with an observation that's sort of indirect, but Sue had the distinction of spending some time in Whitehorse and not seeing the aurora, but she then forwarded these beautiful pictures from her son-in-law, and Sue, did you want to say anything about these?
Yeah, but as need be, I'll be very brief. I did see the Aurora back in 2019, which was an amazing experience. That was in Dawson City, further north than Whitehorse. But yes, this time round it was cloudy all the time I was there. But anyway, yeah, this was quite a surprise, I think, for Justin and Diane, my daughter. They were actually just getting ready to go to bed, and he'd gone over to the window and he just saw what he thought was cloud initially, and then looked at it more closely and realized what it was. And they went outside and were looking at it. It was pretty spectacular, he said, for about 20 minutes. And then he managed to drag himself away, went in to try and find his camera, hoping it was powered up, but it was. So we took a few shots. I think these three, actually, the one without the pink explosion was taken right from their backyard in Whitehorse. And the last one, as he calls it, the psychedelic one, was up a bit further, a higher vantage point. There's a little mountain lookout there about 10 minutes drive away. And so I don't know what the settings are. He did say he'd send them, but he's pretty busy. They both work and they've got a toddler. So, you know, their life is full and very busy. So, you know, I don't know. I'm sure he will tell me if you want to know at some point. But he's got, I think he's got a Canon, actually, a bit like my Pentax K70. He said it's a very similar model, but that's all I can tell you. I know he put his settings on manual. I know that much, but I don't know exactly what they are.
Okay, well, send along our regards and our thanks for sending us the pictures, and thank you for forwarding them to us. They, and we were hoping to maybe see a hint of Aurora recently, but this is better than anything we're going to see here, I think.
Yeah, I know, they're lovely, aren't they? Okay.
Okay, and Robert, so now I'm going to go more or less in chronological order. So about a month ago, so this actually, I guess, was the night of our last meeting. Robert got this one, only some short exposures. The Ghost of Jupiter, a challenging object. Do you want to say a little bit about that, Robert? Just a tiny bit.
Yeah, I was, you know, happy to have gotten that that image, and when if you or if I magnify it, I can actually see the shape of it being very similar to a lot of other better than me astrophotographers. So I was very happy to have picked that up that night, and with especially with the limited sky that I have here in my neck of the woods with all the maple trees around. So that's all that I really have to say about that.
Okay, great, thank you. And Bernard, this was the challenge. This was Nikolay's challenge last month, was to see this quasar, which should be there. And I guess in this picture, is it that one there?
Yeah, that's it.
That one there. So Bernard certainly won that. Well, he fulfilled that challenge and proved it very nicely with the image to the left. And so most people heard the challenge, but the point about that is that's about the farthest thing we can resolve, right? Is that the deal?
The most
That's what
distant,
Nikolay was saying. Yeah.
the most distant object that is accessible to an amateur astronomer.
Right. Okay, so congratulations, Bernard. And so Bernard had another one that was the same night. And so you want to say a little bit about this one, Bernard? The Needle Galaxy, beautiful image.
Yeah, that one turned out pretty good. A little bit of trouble trying to center it up and find it because it's pretty faint. But when I did get it there, you know, it took what is it? That was about a month ago now. Yeah, 120 30-second exposures, yeah, with my 12-inch Meade telescope there. And
Very nice.
6.3 reducer, yeah.
Mhm.
And there's a little galaxy down in the corner there, you can see on that one as well there.
Yep. Okay, and I've got two here from Jim. If Jim's there. And I
Alright.
think that the second one has this data plus some RGB data in it. Jim, did you want to say a word about this one?
Yeah, there's the first image you showed there, which is mostly with the L-enhanced filter. This is sort of like a narrow band picture, and this is over 5 hours of exposure time one night, primarily in H alpha, and then I combine that with over 5 hours of what I would call broadband data. This was taken while the moon was fairly bright, so I was using filters for both of those sequences. So this is a combination of 10 hours of the broadband data and the narrowband data. And the narrowband data in this particular image basically just highlights the very, very bright H alpha regions in M101, which is the pinwheel galaxy. So the rest of what you're seeing there is basically the blue giants and the old yellow, the older stars in the core. So this is by far the largest amount of exposure time that I've ever been able to process. So this is over 10 hours now.
Yeah, very impressive. Great. Okay, thank you. And these ones I'm not going to say much about. That was the same night, so there was lots of moon, but and I was struggling with things running into the power lines and that, but M1 and M78 and just sort of seeing what was there. And then Chris also did, this was the next night, did 3 images. So M101 and then the Owl planetary nebula and then 2 galaxies. So Chris, you want to say a bit about that night?
Yeah, sure. Can you hear me? Yeah, so yeah, Jim and I both looked at M101. I've got a 12-inch, I've got the same telescope Bernard has actually. So his is under much better skies. Yeah, bright moon, so narrowband only. And well, a relatively new narrowband H alpha filter. It's only, the bandwidth is only 3 nanometers wide. So it's really good at chopping out anything but the red light from hydrogen. And so you can see those H2 regions along the spiral arms. Those are star forming regions, all those little red knots. And so they came out rather nicely. But the rest of the galaxy, of course, was absent. So I also took some photographs, some images, again, another 25 1-minute exposures through a green filter, just an LRGB, but only the green. And I use that for both the green and blue channels, and made a color image out of the 3 of them. So that worked out okay.
Okay.
And the Owl, was that the same night?
I think so.
Yeah. The same process for the Owl, a slightly different number of exposures. Practically no H alpha from the Owl Nebula. Planetary nebula are very bright in oxygen 3. So, however, the stars are white, so the amount of starlight that leaked through the red filter, along with the green and blue stuff, resulted in white stars. Most planetary nebulae are blue-green, and the last image is some galaxies in Leo. And again, this is just the H alpha filter, and here they're not colored red. It's just left in the. It's a monochrome image, so they're just left black and white.
Okay, thanks a lot, Chris.
Yep, thanks.
And so then we got into a few clear mornings, and people were taking images of planets, and Randy, I think got off the mark first, and so I think this is Venus and Mars and the moon that morning. So Randy, did you want to say anything more about that, or?
No, not really. It was a very clear moon that morning. So I
Yeah,
actually got up
and,
to see the Venus and Mars, but the moon was a bonus, right?
Yep. And then we started to get into a few days where you could see Venus, Mars, and Saturn. So a few of us did that, and this was my first try. So Venus is easy, Mars isn't bad, and Saturn, in this image, it should be down here somewhere, but I can barely even see it. And so the next night, Bernard did this image of the California Nebula and also caught a comet in it. So you want to say a little bit about how you found that comet, Bernard?
Well, I was just looking at the HAP, use this Sky Safari HAP, and I noticed, just looked up comets, and I noticed that one was passing by there, and so the California Nebula. So I just thought I'd give it a try. So I did manage to get it there on that one, but yeah, so a lot of stars in there, and the nebula didn't turn out really bright, but I did get the comet.
Yeah, that's pretty impressive. So you were hunting for that comet.
Yes, I noticed that on the HAP that it was passing by the nebula, so I thought I'd give it a try. It was fairly low too at the time, but it worked out pretty good. That was with my Sharp Star, the telescope there, 61, the smaller one I use,
Okay.
mounted on top of my Meade telescope.
Okay, so here's another. So this is the next morning. So again, we're getting into a string of planets and the moon in this case. So there's Venus, Saturn down there, and Mars, and John and Andrea Peddle got the same sort of image. And I think this was probably from up in Pippi Park. So the moon with some earth shine, Venus, Saturn, and Mars, and John and or Andrea. There's a series here, so maybe you could just say a little bit about that morning. They were actually on the move from
Yeah, we
Park.
started up at a golf course, but a chalet, and took the first 3 of those pictures. We like to get the city in foreground, a little bit of perspective. And the next 2 pictures, we went up to Signal Hill. It was about a half an hour later, and we got a couple more pictures there. Like you can barely just see Venus there.
Venus, and I thought I could see.
Yeah, on a real good screen, you can zoom in. You can see Saturn below, but I don't think
Saturn might be there.
Yeah.
And I looked real hard. I couldn't really pick out Mars in that one.
No, not on that one, because it was half an hour later, and it's getting pretty bright then.
And then some beautiful sunrise shots.
Yeah, so we waited the extra 20 minutes or half an hour and cut sunrise.
Oh, very nice. Okay, thanks.
Yeah.
And going above and beyond it is Richard. I thought I saw Richard somewhere. You on, Richard? Yeah. Yep. So this one was a morning when nobody else got a shot because it was cloudy. You can see the clouds, but Richard solved that. So how'd you do this?
I was on the plane and heading to Halifax for a training course for work. And I was looking out the window probably about 20 minutes before we were landing, and I could see the moon there and Venus. So I had to take a picture.
Yeah, could you I guess you couldn't see, by then it was probably too light to see Mars and Saturn. They were
Yeah,
probably
it
around
was-
there somewhere.
There was only Venus standing out and the moon at
Yeah.
that point.
Well, that's great. Thanks for sharing that. That was fun to see. And we've also got some sun images. The sun is starting to get a lot more interesting. So Gary did this one on March 28th. Real close up of a very active region. So Gary, do you want to say a little bit about this one?
Okay, the only thing you can see there, actually, I want to point out is that the beard filter is easily seen. That's all those square marks you see.
Oh, yeah.
Yeah, that was a really good blow up. It was only a 2 times Barlow on a 35mm a hydrogen alpha thing, so it's pumping above its calibrator. And the only other thing was I had just changed the blue-green filter. My blue-green filter was destroyed, or it had eroded, or a fungus had grown on it, so I had to replace it, and I couldn't believe how much more detail I've gotten all these 5 years that I've been looking through this crap. But that's it there.
Okay. And I looked, yeah, the same day, probably a different orientation. So there's the sunspot, and this, eventually there was a coronal mass ejection from this thing, and some prominences. And so I'm using a 40-inch Coronado.
You
PST.
wish, you wish.
40-inch.
Yeah, sorry. So late night, 40 mil.
Damn.
Yeah, I have to use a special trailer for that. 40mm PST and the an ASI Mini, and the sensor in the ASI 120 Mini is pretty tiny, so I can't quite get the whole sun on. So I have to take 2 pictures and stitch them together. So that's the first of a few sun pictures from me. So this is a couple days later, and now Venus. This was a morning that was very cloudy, but I was up just before the cloud sort of overtook, just between basically when Venus, Saturn, and Mars were visible, and when the cloud sort of got them. So I got that shot. And then we had on April 3rd, so the waxing crescent moon, there were a lot of us got shots with Earthshine, so I'm just going to run through them, unless people want to jump in and say something. But this was Gary's shot with Earthshine. You can see some features on the moon there. I did the same thing, and I did one with the exposure set, and this was using an 8-inch Dobsonian. One with the this actually, I guess, was the evening. One with the exposure set so that I could see the Earth shine, and one so that I could see the moon. And beautiful shot here from John and Andrea. Oh, and one of the things that was happening was that this star, which is Sigma Arietis or something like that, in Aries, got occulted. So this shot is a little bit earlier, and then John and Andrea had a shot. There's the star there, so it's a little close to being occulted. And Randy saw it happen too. Then I'll invite John to just say a little bit about this one, because he's also caught Uranus in the picture.
Yeah, Uranus is there. Like it was easy to navigate from the moon to Uranus there. And at that point there, Sigma Arietis had gone behind the moon. So you can jump back and forth. You can see one picture is there, one picture it's not. So.
Yep, and beautiful detail in the Earthshine region there. Okay, and then, so this is the next morning. And so Randy, you want to say a little bit about this one?
You got to squint, but both Saturn and Mars are right there. Yeah. Okay. So, yeah, and I left the clouds in for dramatic effect, right?
You waited for the right positioning of the clouds. And then Jim actually did a drawing. So you want to say a bit about this one? This is quite impressive. So that's the image on the left here.
Yeah, I was out observing with the with our Lunt solar telescope, and everyone knows I'm a astrophotography bigot, sort of. So, but on this day, there's no way I could figure out how to take a photograph of this, what I was seeing. So I decided to try to sketch it. So so this is something that I'll probably might do more of in the future, because I'm starting to learn how to actually use the solar telescope, but I haven't figured out how to photograph through it yet. So maybe some more drawings. Now, what's interesting about what I'm seeing through the scope is the amount of surface detail in this shot, in this drawing, is basically the dark, and the dark is the dark part of the sunspot is the cool part of the sunspot, and then there's this little bit of some other detail around the sunspot, which I don't understand as yet, but it correlated quite nicely with the image on the right, which is the spaceweather.com site. So I was actually quite proud. I picked up most of the sunspots in that.
So did you started out, you drew the circle in advance?
Yeah, I did. Yeah, just to keep the dots within some sort of frame. So, yeah.
And so how long did it take you to draw that?
Oh, I did that. If you look closely at the dots, they're all just little smudges of pencil. I think it took about 5 minutes.
Okay. And are you tracking the sun when you're doing that, or?
I am, yes. It's
Okay.
everything is being tracked at this point.
Okay, so you don't have to draw it quickly enough to keep it in the eyepiece before it escapes. Well, that's great.
Just the clouds were coming in at the time. So 5 minutes after this was done, I couldn't see the sun anymore.
Well, thanks. I really like having a drawing here. I think that's really a nice touch. So congratulations. And so this was the same day. So Jim had more detail in his drawing than I could get in my picture, but there's the sunspot, and that prominence is a little bit bigger, I guess, by the time I did it. I did get this nice filament there. And then another, so this was just a couple nights ago, I guess. I did M81 and M82. I actually did that. This was the first night. I did it the second night and got some more time on M81 and M82, but it didn't really help very much. That there was a almost full moon. This was, I think, the night before the full moon, and that, even though this is in the opposite part of the sky, I think it was affecting things a little bit. And then I'll invite Chris to say a little bit about this shot, NGC 2903.
Yeah, this is in Leo again. 1 month later, taking images with a bright moon in the sky again. So out comes the 3 nanometer H alpha filter again. And this is about as far away from the moon as I could get, pointing up in the south. I can't point the telescope high in the north, so M81 and M82 are out for me. But yeah, so it's a pretty a nice pretty galaxy near the nose of Leo the Lion, if you will. And you can see all the H2 regions forming an S towards the middle. And there aren't too many H2 regions along those 2 graceful outer arms in this galaxy. Most of them are in the middle. So I thought that was cute.
Yep. Okay, thanks. And then this is yesterday, so Randy did a shot with his lunt, and there's a big prominence and at least 3 sunspots. So Randy, you want to say a little bit about that one?
Yeah, I'm still like Jim, trying to get shots with a regular DSLR camera. Fine tuning is problematic out in the bright sunlight. Not that we should ever complain about bright sunlight, right? But yeah, there's prominences all around there, and as most of you know, you can't usually get spots and proms at the same time.
Yeah, and so I tried the same. So I guess I have my camera upside down in my eyepiece holder relative to yours. And again, I can't quite get the whole sun on the sensor. So there's the sunspots, and there's that prominence, which in yours, and I don't know, maybe it was Marcel. Somebody, I think it was Marcel's, commented that in this image, sort of the prominence looks like it's got 2 legs, and by the time I was doing it, one of them was starting to dissipate, and so that was the difference was, I think, a couple hours between those 2 pictures.
Yeah. I was watching that prominences pretty closely as well, and you could actually see it change while you're watching it.
Yeah.
I tried taking a movie, but I hadn't figured out how to change the shutter speed on the movie mode, which I do now. So.
Okay. Yeah, it turned out that we used actually just about the same exposure time. So that's the images we had. So thanks everybody, and I'm going to invite Nikolay to jump back in again and tell us what we're going to look at for the next month.
All right. Hello
We're all going to be
again.
looking at satellite data, I think, to paying much closer attention to the satellite images and less to Spot WX now.
I hope so. Can you see this?
Yep.
Okay. All right. So the sky this month. This is the solar system roundup for today. Sunrise is at 6 a.m. Sunset is at 7:58. So we're getting a pretty long day now, almost 14 hours. And then there's the planets with a rise and set time. You can look at that to plan your planetary observing. Here is the latest picture of the sun from today. As we talked about, the sun is getting very active and very interesting to look at. There are 4 massive groups of sunspots, and they are rotating into view. So this is great. If you can look at it over the next few days, highly recommend it. Planets, Mercury is currently undergoing its most favorable apparition of the year right now. It will be visible in the evening at its highest and largest distance from the sun. On April 29th, Mercury will be very close to the Pleiades, providing a lovely sight in binoculars. I think it's just going to be to the southwest of them. So great opportunity, either for a picture or just, binocular observing. And then Mercury will disappear from sight by May 9th, which is when this favorable apparition ends. So you got, 2 to 3 weeks to see this. This is the only evening planet. Everything else is a morning planet. As we talked about, Venus, Mars, Saturn, and Jupiter are all aligned in a line in the morning sky right now. Venus is the bright morning star over the next little while, rising 1 to 2 hours before the sun. Same with Mars. Saturn is also very close to Mars and Venus, rising about half an hour after them. And then Jupiter, which re-emerged from a solar conjunction in early April, during the planetary gathering. And on April 18th, the four brightest planets formed a nearly spaced out, perfectly spaced out line in the southeast. It's still there. It's not, as perfect as it would have been 2 days ago, but it's pretty similar. So it's a very good opportunity to see this right now. On the morning of May 1st, Jupiter will be so close to Venus that you'll be able to see both in the same telescopic field of view. That's pretty cool. Last year, we had the same thing occur with Jupiter and Saturn. It was very neat. I actually remember there was an extra star that looked like it was Jupiter's fifth moon. And it was perfectly aligned with the four Galilean moons. And there was Saturn right next to them. It was just like this once in a lifetime combination. But either way, it's really cool to see two planets in the same field of view. Unobservable planets, Uranus and Neptune, it's going to be another few months before they emerge from the glare of the sun. Comets, nothing worth talking about that I know of. If you've noticed something that's not here, because I do use this website, sometimes there's things that show up and they're not here. Let me know. There's the 5 brightest asteroids, supernovae, the brightest one being 13.7, so not particularly impressive. Meteor showers, there's one coming up in 2 days. So Friday night, there's the Lyrid. I looked at the forecast, doesn't look good. So unfortunately, and it's not a very good one either. It's 10 per hour. But if you want to try on any of the kind of surrounding dates, you might still see something. Deep sky objects, here are the best objects for April and May. And because I know that Mike's going to ask me what's MEL, it's a catalog for star clusters. So that's one of the objects that you'll see here. Everything else is a Messier or an NGC. Why did I not? Wait a second. This makes no sense. I thought okay. Maybe I didn't. Maybe my version didn't update. Let me just quickly, because I did update the observing challenge. Okay, yeah, I'm showing an old version for some reason. Here is the current one. That's the one that I sent to Craig and uploaded. So the April observing challenge is very difficult. Again, another tough one. And thanks to Marcellus for pointing that out to me. So the challenge will be to image the sodium tail of Mercury on or around April 29th. Okay. So actually, from a pure imaging perspective, it's not a very hard thing to do. The difficulty is just having the right filter and kind of experimenting until it works. I don't know a whole lot about it. I've never attempted to do this. But for more details, there's a post on Cloudy Nights. And the user in that post used this filter, 529 bandpass filter. So if you have something similar, or if you want to try a different one, you're welcome to try it, but the details are contained within this post. Apparently it's not a very hard thing to do. The only thing you need is just a filter. And this is the picture that they took. So looks just like a comet, but this is Mercury with a sodium tail. And the reason why it needs to happen on around April 29th is that that's when the greatest elongation and that's how the geometry, I guess, works out with Mercury. It's the highest angle between Mercury, Earth, and Sun. So this is the best time to do it. And with this being the best apparition of Mercury, this is the greatest angle that you're going to get this year. So this is your opportunity to do it. I don't know if anybody has ever seen or attempted or anything like that. I don't know if other filters would work. I don't know, Chris, if you know, because you know a lot about filters and wavelengths.
Yeah, I don't own a sodium filter. It's possible to tune narrowband filters blueward by tilting them, but I don't know if you could tilt it enough to take an H-alpha filter down to sodium. Well, it's 9 days if you want to pay the shipping. Get it rushed in.
Yeah.
So it's a yellow filter, but I'm getting that narrow a band. I probably just a yellow filter out of your box of filters may not be narrow enough.
I don't think so. It says a 10 nanometer bandpass. So this is a narrow band filter that isolates the sodium doublet, the D line, which clearly fluoresces in sunlight. So it's the same yellow we get from sodium streetlights. So that's quite a challenge. Well, we'll give it a shot.
Maybe if anyone can just get a photo of the planet would be sufficient.
You get half points for that.
Okay. I'd still have to leave the backyard observatory because the house blocks the view west. So that's a road
You
trip
need
for me.
the opposite of a light pollution filter.
Yes, that's exactly right. You need something that only passes light pollution.
Okay.
I wonder if a light pollution filter because they reflect the colors that they don't transmit. I wonder if a light pollution
If you
filter would
reflected
actually be
mercury in a light pollution filter,
it would reflect sodium light. So I don't know. I'll have to think about that.
yeah, let me know how that turns out.
Yeah. I think I'm just going to go for Mercury in the Pleiades. That sounds like a pretty shot.
Yeah, that's the same date. That's the 29th.
Yeah. Of course, it needs to be clear. So
All right,
Someone
let's
just brought
move
a
on.
telescope.
Yeah, John Nugent bought a telescope.
Shows you clear sky.
And Sue as well, I think, right?
Oh, okay. Double whammy.
Yes, I do have a new telescope, but it's still in the box.
and I've got optics for a spectrograph coming in on Friday, so it's a triple whammy.
Yeah.
Oh dear.
Okay, I don't know what happened with my presentation. It doesn't look right, but I'll send Craig another one and make sure that it's good. But that's all I have. I just have the observing calendars, which we don't use a whole lot, when there's no sessions. But yeah, that's about it.
Okay, thank you very much, Nikolay. If you want to stop sharing, I'll wrap things up then. So in terms of news, May 7th coming up, it's before our next meeting, is International Astronomy Day, and we're planning to do something at the Geo Center. We'll try and have some solar observing, and we're still figuring that out. Gary, do you want to say any more about where we are with that, or?
No, they're looking forward to us, and I just got an email today asking us what they want us to do, or what we want them to do. So I guess we have total control.
Do you know what the situation is with the windows, if we're going to have something in the lobby?
Nope, I never got any information on that today.
Okay,
So I
so
don't know.
we will send out information about that as we get a bit closer, but we'll be sort of getting into planning mode pretty soon. And our next meeting is going to be a members meeting. So I'd invite people to, if they want to give a very short talk about a project or some new equipment they've got, or some new equipment they've got questions about, or just some more extended discussions of observations they've done, drawings, visual stuff. You could, probably the easiest way is to email Randy, and he can sort of pass it along, and we can sort of fit things together. And so that's kind of the news that I had for right now. And we're pretty late, but if anyone has some questions about their equipment or wants to have some discussion, we can sort of stay online for a little bit. Otherwise, I think that kind of wraps up the formal agenda for the meeting, and thank you all for coming.
Nikolay, the correct sky this month is on the website. It has the Mercury challenge.
I just saw that, but for some reason the tables at the bottom are not formatted right. So I just resent it to Craig, and
Okay.
Maybe it was just the PDF version of that.
Yeah.
That was bad, but.
So your bandwidth seems to be getting funny again, but
yeah.
Good thing that when you're doing your presentations, it seems okay, and then when you're finished, you've tired it out or something.
I think it sounds pretty cool. It sounds like a Cylon or something.
I have a question, if it's not too
Yes,
late.
please.
I just wondered if you could fill me in on the rules for going to Butterpot. Are there any? Or if you're a member, can you just go, or do you have to get a pass for the year with the park? Or I was there many years ago when I was at MUN, so it's been a while, but
So I'll let one of maybe
you.
Randy or Robert say something about how that works. We're normally, I think, able to just, when they're open, you can go up and just tell them that you're with the RASC. Normally, we kind of plan a time when we're doing it. But Randy or Robert, or
Thanks.
someone want to say something about how that works?
Well, we haven't been up there for, of course, since pandemic. So
Right, yeah.
some of us may have forgotten and or lost touch with.
Well, we had two areas that we used. I don't know that you'll be able to go on past the main guard gate and go on down into the park proper. Our observatory platform is before you get to the guardhouse as
Right,
well.
okay.
We usually go down to the day use area down by the beach. And again, all you need to do, tell them you're with the RASC and you're going down observing. They've never stopped us.
So say if I wanted to go tomorrow night or something, I mean,
Well, they're not open right now. We do, if we were doing an organized session,
okay.
We would have a key to open up the gate, which
Right.
we think still works, but I guess Robert checked it in the fall.
Yes, that's correct. And the key still works. So if we were heading to the park, Peggy, then, you know, the membership knows, and you kind of show up at the appointed time. And we usually go in as a group then.
Okay,
But,
no, that's good to know, yeah. Okay.
Yeah, but if a person was coming outside of that, if it's in, if it's during the part of the year when the park is open, well, the front gate is unlocked and open anyway. So then you'd simply, go on in and stay to the right-hand side of the kiosk. And that's the roadway that would take you down to the day use area. And of course, you'd stop at the kiosk and just
Right.
take a picture with the RASC and they would just grant you access. And so you just drive on down. But if it's during the part of the year when the gate is locked, that's when we would, have a time set to arrive at the gate, and then we'd open it up and go on in.
Okay.
But if somebody did, was unable to meet that particular time, then they would arrive at the gate to find it locked, and we would already be in there, but then you'd have a phone number, and you would
Okay.
call one of us, and we'd come out to the gate and unlock it.
Okay, no, that's good to know. I didn't know if I could just, stroll on in or whatever, but
Yeah, and we
The gate's
usually
locked.
had an email with instructions that we would send out as well.
Yeah,
And-
we
But
should maybe
since
think about trying
COVID
to do it again pretty soon, because I think
Yeah.
we're getting to the point where we could probably distance enough to.
Peggy's
Yeah.
on the talk list as well, so we usually chat about
Yeah,
that there. right?
okay. Oh,
Yeah.
that's great, thanks. Okay. I'm just
But-
looking for somewhere to go because I've been going out the last little while.
Yeah.
And just driving out to Holyrood or so by yourself, like 3 o'clock in the morning, it's kind of creepy sometimes. So I thought that would be a good place to hang out,
Yeah,
but
you gotta be careful of the ferries.
yeah, exactly. Ferries
think
name
we're all-
people. Sorry.
No, I was just gonna say, I think we're all really missing group observing. It's been over 2 years now, or 2 years, so. We're all looking forward to getting back to it, I think.
Yeah,
Uh,
but
certainly safety.
thanks for bringing that up. And Cynthia was reminding me that the park opens, I think, on May 24th.
So
the week
another
of
month,
May
okay.
24th.
All right. That's great, thank you. Thanks.
And if you haven't been down to the day use area, the road is pretty heaved. So be prepared to drive very slowly and sort of creep over all sorts of stuff. And there are a couple moose down there too.
Yep. And they won't
Been
move.
there during the day, but never at night, so, okay.
Yeah, don't try and drive over that road in your low rider downtown cruising,
Yes.
whatever.
Yeah, we have a car that doesn't go there.
I was noting on the chat that the moon is a big draw for people. The other night with full moon, the lineup of cars at the top parking lot was way down around the curve. I mean, almost halfway down to the Interp Center. And I was chatting with 3 or 4 photographers there, and just regular people wanting to take a picture of the moon and stuff. So it's quite a draw.
And the lookout over top of Middle Cove was a draw the other night too. There was a small crowd there, and that's actually pretty dark there. There's no street light, and there is a little platform, but could only accommodate a couple people.
And it's usually windy.
Yeah, that's a problem.
The people tend to park parallel to the sidewalk rather than face in. So if you're there, all along comes a car with the light shining right in your face, typically, right? So there is a little platform down below, though. That's from our Aurora trips, right?
Well, I'm in the East End, so that's where I dash whatever there's possibly Aurora to be seen.
A little bit further for me, but still, it's only 20 or 25-minute drive down the outer ring. So I'm switching. I'm using a DSLR these days, but I'm about to switch to a a regular camera like you guys are using, the MM120 and stuff, but I have some video cameras, and I bought an electronic focuser. My intent is to be sitting in here looking out at the telescope instead of blinded out, hunched over it. So we'll see how that works out. Because you have to refocus for prominences or spots, right? So, as well as typically I'm shooting about what, 1/100th of a second for spots and 1/3 of a second for prominences.
Yeah, with my 40-inch,
Yeah,
I don't have, I can
Yeah.
more or less get
Yeah.
both of them.
even Dave Newbury is not that big, right? Plus
Yeah.
Dave's 100 millimeter or 120. I forget what Dave's was.
Yeah, no, for the 40mm one,
Have you?
but it's very touchy. There's
Yeah.
sort of one spot that you can get the filter that you can more or less see everything, but
Yeah,
Have you thought
it would
of-
be a compromise.
Have you thought, Mike, of maybe putting in a like a 0.8 or 0.9 reducer, and so you can get the whole sun image?
I've got a 0.5 reducer. That's probably too much.
Yeah, it's too small.
But
So let's
the
try to stop-
problem is that the focus
focus. Yeah.
is inside the tube, so that this is
Mhm.
a very small telescope with a tube, and it actually focuses in there, and you don't focus by moving the eyepiece up and down like a real telescope. There's basically in the diagonal, you just sort of move the reflector a little bit to focus. So it's I have thought about maybe trying a Barlow, move the focus out a little bit.
Barlow would go in the other direction, wouldn't it?
Well, it moves the focus out, doesn't it?
Yeah.
Yeah, it would make your image larger instead of smaller.
Oh, yeah, so and then what I would have to do, I would
Oh,
definitely
Barlow,
have
and
to
then
do,
you're 0.5.
Then reduce it.
sorry,
Yeah,
the
well,
thing with the Barlow is the Barlow might let me use the DSLR, which has a real chip, rather than the chip in the 120 it's a few millimeters.
But most of the
So it's a
Barlows,
really
most
tiny
of the
chip.
Most of the Barlows that I have a tube, but you put your eyepiece thing down in, and on the bottom is the actual glass. So most of them I unscrew them and I screw them into the nose piece for the camera, and just happens to fit perfectly, right? And, so because
I was going to have a look at that and see if that would work.
It's you have a 120 mm. You have an eyepiece camera, right, Mike?
Yeah.
Yeah.
Yeah, the front end of that is threaded for all of these. You can thread on things. So
and filters as well, right?
Yeah.
Because I
And
use
it's something to play around with.
there you go. Excellent sun pictures there, Mike. Oh, the detail is astounding. And again, you're getting it both. That's a real art to do that.
So what I do is on the curve, I pull up at the extreme left, so that's sort of the low brightness, I guess, and that brings up the prominences, and then just to the right of that, I pull down, so my curve ends up looking like up, down, and back up again. And that's how I get both of them in at the same time.
You're showing about the histogram, right?
Yep. Yes.
Yeah. Anyways,
Well, gents, thank you very much. I'm fading here.
yeah. So thanks again, Nikolay. That was a great talk. A little bit intimidating. There's more to it than I thought. But
He
I
didn't
think
even
it's
get
something
into
that it's worth maybe trying and getting some practice with, and Because I've always just looked at spot wicks and
I like, sorry, Nikolay, Mr. Cylon. I like the COD, the College of Dupage.
Yeah.
COD, so I have to go back over now and remind myself where to find, because the when you say infrared, I keep thinking the 10.7 micron stuff on the Environment Canada site, where you see very cold cloud tops, you know, where there's convective cloud, but the more subtle stuff is, you're saying the 2.2 micron stuff?
There's a lot of different ones.
Nikolay, could you put the
That link is on our website, by the way.
what's that?
The link to that site is on our website.
Oh, okay. I was going to say, could you post
Okay.
the link somewhere? But if it's on the website, that's good.
I
I was
just
going
want
to
to
suggest
use all the
maybe
time.
putting it on groups too.
I'll start using that. Thank you. That's,
I've been using it since Nikolay alerted me to it. I don't know, maybe 2 years ago. Since the last time he did a presentation similar to this, and that's where he introduced that website at the time.
well, I just want to alert people that Peggy, before she left, left a nice comment in the chat.
Anyways, we should probably wrap it up. Thanks, everybody.
Good night.
Great meeting.
Have a good visit away, Nikolay.
Thank you.
And happy Easter coming up this weekend, is it?
Oh yeah, we're celebrating.
Good.
Yeah, and take a pill for your voice.
Yeah.
Okay, bye, everybody.
Good night.